Dear student, this is a question of the network analysis, and here they have added this battery at t is equals to 0. That means at t is equals to 0 you have applied the source, and you have to tell at which value of t you will get this I will be 2 ampere. That means what will I do? I will firstly calculate what is the current here, then I will apply the current division rule there. That means firstly I will calculate what is the value of the current from here. Now see, if before t is equals to 0, if you are applying the voltage at t is equals to 0, that means at t is equals to 0 minus, there should not any source present in the circuit. And if it is this passive network does not have any active component before t is equals to 0, that means this initial current of these two inductors will be 0. That means I can replace this circuit like this. For the primary calculation, that means I am assuming the current is I here, sorry, I dash, and I will calculate this small I first. That means the total equivalent resistance will be 2 by 3 Henry. Parallel combination of these. That means firstly I will calculate the current from here, then I will apply the current division directly. That means here the value 1, and here this is the voltage source of 15 volts. This is the first order circuit. Okay, and at infinity this inductor will behave as a short circuit. That means the I of infinity will be 15 divided by 1 is equals to 15 ampere. And if any source is not present before t is equals to 0, that means I of 0 minus equals to I of 0 plus is equals to 0 ampere. Here only single resistance, that means the R equivalent is 1, and L equivalent of this is the 2 by 3 Henry. And as we know, we have the shortcut also of this. That means the shortcut of this is something like this: I of infinity minus I of infinity minus I of 0 e raised to minus t by tau. We know what is the value of I of infinity? 15 by 1. That means 15 minus 0 e raised to minus, the tau value is L by R. That means 3 by 2 t. Now here, this is the total value of I of t. That means the current from here. This is the current. I can simplify this: 15 minus 15 e raised to minus 3t by 2. This is the current of I of t. That means current entering from here. Now here two inductors are in parallel. That means we can apply the current division. Okay. Now I am assuming the current is capital I as they have asked. That means the capital I is equals to 1 divided by the total 1 plus 2, 3 into this small I. That means I by 3 is your capital I. That means just divided by 3 and you will get I is equals to 3. 5 minus 5 e raised to minus 3 by 2 t. This is the value of the current I, and which is exponential. That means with respect to time. That means whenever you will decrease this at t is equals to 0, the current will be 0. Slowly this current will increase. That means something like this, and at the last it will go 5. You have to tell the current at t is equals to, that means the magnitude of the current is 2, and you have to tell what is the time here. This is the proper question. Now that means I know the current is 2, and I have to calculate this term. That means you just have to minus 3 divided by minus 5 e raised to minus 3t by 2. Minus minus will cancel out. Whenever you will take this, that means it will become 1 by 2. That means minus 3t by 2 will cancel out. T is equals to 1 by 3. This is, and this is seconds. That means if you want to put in the numerical type answer, 0.33 seconds.